So we're in section 11.6. And we're talking about surface area and volume of spheres. So our spheres are nice because we don't have to worry about a base, we don't have to worry about a height, we don't have to worry about lateral surfaces, we don't have to worry about edges, we don't have to worry about vertices. All we have to worry about with a sphere, because all a sphere is, the entire thing is a curved surface. So we have a 3D curved surface. So we can think of everything being the lateral side. So the whole thing is curved. The way we define a sphere, and folks, let's put the electronics away, please. The way we define a sphere is all the points that are the same distance from a center. And what do we call that distance for the sphere? The distance from the center is the radius. The distance is the radius. So the only thing we have to worry about with a sphere, the only thing that matters really for our formulas, is the radius. If we want to draw a picture of a sphere, I would start with a circle. Well, there's my circle, there's the edge of my sphere, and I'm going to draw the diameter around here. So we'll cut our circle right in half to get our diameter, and then that is our center, and this would be our radius. Go from the center to the sphere itself, and that would be R. So for all of our formulas, surface area and volume, all we need is the radius. That's all we have to worry about. So that makes spheres kind of nice to work with. What's a hemisphere? What's that? So it's a part of a sphere. How much of a sphere is a hemisphere? Half. Hemisphere is half a sphere. So if a question asks you about something about a hemisphere, a dome that's a hemisphere, it just means half a sphere. And when we're talking about the globe, the northern hemisphere, the southern hemisphere, talking about the northern half of the globe, the southern half, so a hemisphere is half a sphere. And just as a kind of a sideline hemisphere, the engines that they call hemis, they call them hemis because the tops of the cylinders are hemispheres. So there's a connection between hot rods and geometry. So that the hemisphere on the top of the cylinder head, on top of the cylinder, gives you more compression in the chamber. So that's why they call them hemis. So the formulas, we can't come up with we can't cut a sphere into a net easily. It lets us figure out where our formulas come from. It's a little more complicated than that. So we're just going to talk about what the formulas are and do some examples with our formulas. It's that's one place that the spheres aren't quite as nice, that we can't just make a net and show where the formulas come from. So let's look at our volume formula. The volume. Volume of a sphere. All we have to find is, for our sphere, is the radius. The volume is going to be 4/3 pi r cubed, units cubed. And all we need is the radius. So I want to do a couple of examples of calculating with our formula. So the key to a sphere is the radius. For our other shapes, the key was the base. Named it by the shape of the base. We had to find the area of the base for everything we did. All we have to do here is find the radius. So let's say we have a sphere. Start with an easy one. Diameter is 24 millimeters. We want the volume in terms of pi. Well, there's our formula. Volume equals 4/3 pi r cubed. So what is our radius here? 12, half the diameter. So our radius is 12 millimeters. Plug that in. The volume is 4/3 pi times 12 cubed. In your calculators, I want to show you how to do the cube in your calculator. Some of you may know already. So I'm going to do 12, and then I'm going to use this little up arrow button. 12 cubed, and I get 1728. The little up arrow is our power button. So I go back here. This is 4/3 pi times 1728. Some of your calculators, on some calculators, they don't have that up arrow button. They have a button that says y to the x, something like that. And you would do 12, and then you hit that y to the x button, and then you hit 3, and then equals. So it kind of works the same way. Some calculators have this button instead of the up arrow button. All right, then I want to keep my answer in terms of pi, so I'm not going to multiply pi out. How do I find 4/3 of 1728? What is this telling me to do? Divide by 3 and multiply by 4. So this is telling me multiply by 4, divide by 3. I could do it either order. I usually think of it as multiplying by 4 and then dividing by 3. So what I'm going to do here is the volume equals 4 times 728, and then I'm going to divide that by 3, and I'm just going to leave my pi out there. So 4/3 is the same thing as saying multiply by 4, divide by 3. So my volume, when I multiply 1728 by 4 and divide it by 3, I get 2304 pi, and I get cubic millimeters. So 4/3, same as multiplying by 4, then dividing by 3. All right, let's look at another example where we have to do a little more figuring. So this one was easy. All we had to do to find the radius is divide the diameter by 2. Okay, so for the next one, we have a ball with a circumference of 25 inches. What is the volume? All right, so our key is the radius. Do we have the radius here? We have the circumference. How can we figure out the radius? How do we find the circumference of a circle? Circumference equals anyone? Diameter times pi, or 2 pi r. Circumference is 2 pi r. So this will let me figure out the radius. I know the circumference is 25, so 25 equals 2 pi r. I'm going to divide both sides by 2 pi. And I get r equals 25 over 2 pi. Plug this into my calculator. I'm just going to divide 25 by 2 and then divide by pi. I get r is about 3.98 inches. Now I'm set. At my radius, I can find my volume. The volume equals 4/3 pi times 3.98 cubed. So let's go to our calculator. I'll calculate this in the calculator. So I'm going to do 3.98. I'm going to cube that. 63.04. I'm going to multiply that by 4. Divide it by 3. And then I need to multiply by pi. So let me see, where on this calculator is my pi button? Do I have a pi button? Right there. Times pi. And I get 264.1, essentially. So my volume is 264.1 cubic inches. Cube 3.98, multiplied by 4, divided by 3, and then multiplied by pi. Questions on that example? All right, let's talk about our surface area. How we find our volume, let's talk about surface area. Surface area of a sphere. Our surface area, nice easy formula as well, 4 pi r squared, unit squared. R is the radius. So again, all we need is our radius. Our radius tells us everything we need to know about a sphere. So let's look at a couple of examples of calculating with this surface area formula. So we have a baseball. And our diameter is 2.9 inches. We want to know how much leather do we need to make the cover. So what is this question asking us? It's asking us what the surface area is, right? The leather, the cover is going around the outside. It's talking about the surface area. So this question is really saying, what is the surface area? So once we figure that out, we're in pretty good shape. We know that our surface area is 4 pi r squared. What's our radius here? 2.9 divided by 2. Diameter is 2.9. We divide that by 2 to get the radius. So 2.9 divided by 2, I get 1.45 inches. And I'm going to plug that into my formula. So our surface area is 4 pi times 1.45 inches squared. And I'm going to calculate that in my calculator. So let me go to my calculator, clear that out. I'm going to do 1.45. I'm going to square that. I'm going to multiply that by 4. And I'm going to multiply that by pi. and I get 26.42. And I'm going to say 0.4 round to the 10th. So I need about 26.4 square inches of leather to cover that baseball. All right, questions there? Okay, let's take a look at another one where we're going to have to do a little more figuring. The volume, a sphere has a volume of 1,000 cubic meters. What is the surface area? So this one takes a little more work. What do we need to do? We have to find the radius. That's our key. Our key to our sphere is a radius, or to keep the sphere is a radius. So we need to find the radius. How can we find the radius? Well, we know the volume is 1,000 cubic meters. So we know our volume is 4/3 pi r cubed. Well, our volume is 1,000 cubic meters. So 1,000 equals 4/3 pi r cubed. I can solve this for r. So I'm just using my volume formula to figure out my radius. So how are we going to solve for the radius here? Divide by 4/3 pi. So first let's turn 4/3 pi, let's just turn that into a decimal. Let's multiply pi by 4 and divide by 3. So 4/3 pi, I'll do this over here. 4/3 pi, multiply pi by 4, divide by 3. So let's do that in our calculators. We go over here to my calculator. 4 times pi, and then divide that by 3. I get 4.18, I'll say 4.189. So then I just put that in here, so 1,000 equals 4.189 times r cubed. And then what Mitch said was let's divide by 4/3 pi. So 4/3 pi is just this number. So I'm going to divide that by 4.189. So I get r cubed equals, when I divide 1,000 by 4.189, I get 238.72. And this is r cubed. How do I undo this cube? We have to do the cube, we call it the cube root. So we need to use the cube root. Square root undoes a square, cube root undoes a cube. So the cube root looks like this, with a 3 there. So in your calculator, let me show you how to do a cube root in your calculator. So most of us, if you have a calculator like this one, our cube root is going to be, I'm going to use this button here that says X and then with the square root sign. So I'm going to put a 3 in there to tell it it's my cube root. Then I'm going to hit that button, and then I put my number in there that I want. What did we have? 238.72. And the cube root of that is about 6.2. Some calculators work a little differently than that, but most of your calculators that we have are going to have something that looks like this. So we use a 3 to tell it we want the cube root, use that button, and then I have 238.72, whatever I'm taking the cube root of, to get my answer. So 6.2. So that tells me that R, my radius, is 6.2. All right, am I done? No, what did the problem ask us to do? We want the surface area. So now we can plug that radius into our surface area formula. So the surface area is 4 pi 6.2 squared. And when I plug this into my calculator, 6.2 squared times pi times 4, I get that, that the surface area is 483.1 square meters. So if our volume is 1,000 cubic meters, our surface area is about 483.1. Questions there? All right, let's look at one last example, kind of related. So let's say our sphere has a surface area of 500 square meters. And we want to find the volume. So what are we going to do here? What's that? We know our surface area formula, right? Our key is to find the radius. So we want to find the radius. We know the surface area, and we know our surface area formula. So we know that the surface area is 4 pi r squared. So 500 is 4 pi r squared. So I want to solve for r. So I'm going to divide both sides by 4 pi. So let's go to our calculator, divide 500 by 4 pi. So I'm going to do 500. Oops, not 5,000. Clear that out. Go. 500 divided by 4 times pi. And I get 39.789, rounded to 789. So r squared equals 39.789. And we know where to go from here, right? To undo this square, what do? Square root. Since we just have a square, we can use a regular square root. So we'll take the square root of 39.789. So I'll go back to the calculator. I'm going to do the square root of that number. And I get about 6.31. So my radius is about 6.31 meters, and now I can find the volume. Our volume is 4/3 pi times 6.31 cubed. So let's calculate that out. So I'm going to do 6.31, cube that, multiply it by 4, divide by 3, and multiply by pi. And I get 1,052.4. And my units would be cubic meters. So I can use the surface area formula to find the radius. I can use the volume formula to find the radius. And once I have the radius, then I can do whatever else I need to do with the radius. Questions there? Okay, so spheres are our easiest shape. All we have to worry about is the radius. Our formula's not that complicated. All they have in them is the radius. We just have to, the only kind of tricky part with our spheres is in our volume formula we have this r cubed that we have to keep track of. And so if we're going the other way, we need to make sure we know how to do a cube for this. Okay. Our homework.